Okay, let's get to the last section in our Unit 4 material. This is about El Nino and La Nina. What these are changes in patterns of circulation of wind and water in the southern Pacific Ocean that change the availability of nutrients and actually change weather and conditions all over the globe. So let's take a look at what this is, what causes it, and what are the effects from it. I'm going to remind you first of these Pacific currents and these, not just Pacific, but all over the globe, these large scale water circulations called gyres. Remember, we have 5 of them, and they go clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. And these are currents of warmer and colder water that do predictable circulations. Sometimes these things change a little bit. So we're going to take a look and concentrate in here on the South Pacific Ocean. Before we get to the changes in an El Nino or La Nina, we got to talk about one term that brings nutrients up from colder water, and this is called an upwelling. So let's take a look at what an upwelling is. An upwelling is when you have surface winds along the surface of the ocean that are pushing warmer water away from the shoreline and causing a circulation to happen where deeper, colder water comes up from the bottom to replace that warm water. What is cool about deeper and colder water? Colder water holds more oxygen and it has more nutrients in it. The nutrients feed the phytoplankton and the zooplankton. The fish feed on those two things. And then you've got fish eating seabirds and larger fish. And then basically, this creates great conditions for productivity and a really good food web. So, this is called an upwelling. Colder water coming up from the bottom, bringing nutrients with it. Let's take a couple of minutes to look at some different pictures of upwellings. Here are some zones along different continents where you might find upwellings. These don't really happen out in the middle of the ocean. They happen more along the coastlines, western coastlines of continents. Okay, let's take a look at here. Upwellings, again, occur along steep western coasts of some continents. Here you see our wind moving our water offshore. This water at the top is warm. It's very poor in nutrients. This water down here is cold and nutrient rich. So you can see I can get more nutrients coming up from the bottom in an upwelling. Here's another picture. This is a little zoom in of an area in Northern California. You can see my wind pushing my warm water offshore, and here comes my colder water from the bottom. All kinds of fish and whales and phytoplankton and zooplankton here. Here's another look at the same idea, but with looking at the temperature. So here's San Francisco, here's Monterey, California, here's my offshore flow of water. You can see the warmer water is moving out from the shore, bringing up a vacuum here where I can bring that colder water up from the bottom. Now, that's the normal pattern. Every few years in the Pacific Ocean, something changes. Normal shore upwellings are affected by changes in the weather. Normally, tropical trade winds go from east to west, and they take warmer water towards Asia, Southeast Asia, which allows that upwelling to come up from the bottom closer to places like South America. But in an El Nino year, those tropical trade winds weaken and most of the time reverse direction. So instead of going from east to west, they would go from west to east, which means warmer Pacific waters move towards South America, not away from South America. What this does is it suppresses that normal upwelling of cold, nutrient-rich water. Let's take a look. Here is a picture on the top of normal conditions, and what you can see is a high plankton concentration in this level of the water right here, and this colder water coming up from the bottom with that upwelling, and it's bringing my nice layer of nutrients. In an El Nino event, even though these arrows don't look much different than the picture above, look at the thick nutrient depleted surface layer here. Now we're devoid of nutrients. I've still got cold water at the bottom, but it's a much thinner layer. It's not coming up as far. It's not bringing those nutrients where they need to be. Reduced supply of nutrients provided by that upwelling. That means decreased plankton, decreased phytoplankton, decreased zooplankton, decreased fisheries, maybe not as many seabirds, just changes the whole system. Here is another picture that shows you finally with the winds and where they're supposed to go. So here's a normal year at the top. I've got my trade winds going from east to west. That is pushing my warm water towards Australia and Southeast Asia. And this whole area in red is warmer. And this is my colder upwelling along the South American coast, bringing my nutrients. Here's an El Nino year at the bottom. The winds have weakened and they have actually moved and changed direction. Because they changed direction, now my warmer water is going towards South America and my upwelling here is reduced. And notice up here in the United States and into Canada, it says warmer winter. So this whole phenomenon here that's happening in the South Pacific does not just affect right here in the ocean, it affects the whole globe. Let's see how it does that. Here are some possible effects of an El Nino. Obviously, decrease in nutrients and reducing primary productivity and decline in fish populations, all here in these areas where that normal upwelling would occur. But this can also alter the weather of 2/3 of the globe. It's going to be a lot drier here in the South Pacific. They could have droughts, they could have fires because that warmer and wetter area of water is going towards South America instead of Southeast Asia. So it's going to be drier here. It's going to be possibly wetter and cooler in the southeast U.S., wetter in the southwest U.S., warmer up here in Canada and the northeast U.S., warmer here in the Pacific areas in Asia and India and China. All kinds of things are happening here just because of this El Nino change in circulation. So here's another picture of that. Here is what happens in an El Nino. I've got unusually high rainfall, South America, and in places in the U.S. and a little bit in Africa. I've got a big area of drought here in Southeast Asia, and I've got an unusually warm periods in these red circled areas. Here's another picture of how this works. A normal condition year, this shows you the colder water coming up from the bottom and the line, the thermocline between warm water and cold water. Here's my winds and my waters going from east to west, and here's my surface winds are blowing westward. Now here's an El Nino condition year. My thermocline layer has dropped. So my water is warmer up here off South America. The cold water's here at the bottom. It's not coming up quite as much. And my warm water flow is stopped or reversed, so it's going towards South America now. This is bringing drought in Australia and Southeast Asia, and it's causing a lot of storms here in America. Now that's El Nino. What is La Nina? La Nina looks like it is just bringing back the normal conditions of how things are supposed to be, but it's actually a little stronger than normal. So think of La Nina like the regular year, but extra. There's some more conditions happening that reverse it back to normal, but even stronger than it was before. So in a La Nina, I have my winds going again from east to west, but it's going to cool some of the coastal surface waters. It's going to bring back the upwellings, but it's a little more than what would normally happen. So if I take a look at in La Nina, what does La Nina cause for us? It causes more Atlantic hurricanes. It causes colder winters in Canada and the northeast U.S., and warmer and drier winters in the southeastern and southwestern U.S., more wildfires, wetter winters in the Pacific Northwest, torrential rains in Southeast Asia, because you remember that wind and that warm water is coming back towards Southeast Asia, and lower wheat yields in Argentina. So they're just not going to have as much rain or conditions here that would be good for agriculture. So look at all of these effects just from what's called a La Nina, which is a extra reversal of El Nino and more normal conditions. So these southern oscillation currents can have a lot of effects of weather and climate and weather events all over the globe. So just take a look at where the circulations normally go, what happens in each of these years, and what are the after effects of all of that. If you want a little video that kind of explains this a little bit better, you can find lots of them, but this one here is linked in Schoology for you, and it gives you a quick little explanation of El Nino and how it works. So go take a look at that, and We will talk more about this in class, and that is El Nino and La Nina.